Okay. Oh, I just heard it start. So, welcome everybody. I hope you had a good day. So, this is our session, the intermediate just-in-time session on equations and inequalities, knowing our learners. The last couple of times we've done things a little differently, and we're going to do things a little differently tonight too. We're going to do a live portion of the session that is specifically focusing on inequalities, since that's sort of the newest part of the 2020 curriculum. And then Rhonda has made us some wonderful videos on the SEL focus for this topic and the idea of initiation within executive functioning. There's two different videos. So when the live portion is done, you can watch those videos right away if you would like. And Rhonda and I are going to stick around for any questions. Or if after the live part you have other things you need to do, you want to watch the videos at another time, that's fine too. And of course, as Grace said, if you have questions about other things after the live portion is done, we're happy to answer any questions. So here we go. So this is the teaching and learning support staff. And so myself, Lene Bates, and Rhonda Hewer are here to support you with intermediate math. So today's agenda for the live portion. So we're going to have a look at those new expectations that are part of the 2020 curriculum as far as equations and inequalities go. We're going to have a look at how you could potentially organize some subtopics within that topic and where inequalities might lie. We're going to have a little look at inequalities themselves. And of course, using that context of how we get to know our learners. And you'll have an opportunity today to think about your learners in mind in terms of our work with inequalities. And then, of course, as I said, when the live portion is done, you can watch some videos. So the new 2020 expectations. So this first slide is actually just, you'll notice the overall expectations up top there. And you'll notice the expectations for grade 6, 7, and 8, they all say the same thing. We also want to be showing you what students are going to be doing in grade 9 so that if you are a grade 8 teacher, you can sort of see that connection there of the overall expectation that's comparable. Interesting of note, the purple part there, you'll notice that C 1.1, they have to research an algebraic concept to tell a story about its development and use in a specific culture and describe its relevance in a current context. So it's kind of a cool new expectation in the grade 9 curriculum. So when we look at the more specific expectations, I'll let you have a look there rather than me reading them to you, but I'm wondering if that top expectation, if anybody can put in the chat there, what you notice about the differences between grades 6, 7, and 8. So what are the main differences there in C 2.2? Yeah, so Lindy's got that grade 8 is rational numbers exactly. So all three grades there say evaluating algebraic expressions. Grade 6 is with whole numbers and they only go to the tenths with decimals. Grade 7 whole numbers and decimals. Grade 8 is rational numbers exactly. And then you'll notice similar things there. Thank you, Rhonda. Rational numbers are positive and negative fractions as well. In C 2.1, you'll notice some difference with the verbiage. So in grade 6, they're adding monomials. In grade 7, they're adding and subtracting monomials. Same thing in grade 8. In grade 6, they are doing that with whole numbers. Grade 7, they're doing that with whole numbers. And with grade 8, they actually do look at binomials as well. And just like with C 2.2, they are doing that with integers as well. And our next specific expectations there, Same thing, grade 6, 7, and 8, they're all solving equations. In grade 6, it's with whole numbers. Grade 7, they include decimals. Grade 8, it's decimals and integers. And then with our solving inequalities that we're going to look at today, that we have with the grade 6s, they are solving inequalities with 2 operations using whole numbers. In grade 7, they are doing that with multiple terms and whole numbers. And in grade 8, once again, it involves integers. And you'll notice that all 3 there are verifying their solutions and graphing as well. So what we want to move into now is how you might organize the subtopics in the overall topic of equations and inequalities. So some people have been diving into this book by Peter Liljedahl, Building Thinking Classrooms, where he talks about using a list of subtopics within a topic. So subtopics can help us as educators understand the progression of ideas within a topic, but it can also really help our students. So you'll see the quotation there, being explicit about the list of outcomes that constitute a unit of study helps students understand that a topic is comprised of a collection of subtopics. So in a second on the next slide, we're going to look at a sample navigation tool where you can list subtopics. And there's a variety of ways you can use this. So it does allow students to see where they are and where they're going. It allows students to navigate their own learning so they can see where they are within the topic. It allows students to think about their own learning. So if they remember sort of things from the subtopic prior, or if they know anything about what's coming up, it can allow for students to do their own self-assessment. So when we see the navigation tool, it could be used for students to evaluate their own understanding of each subtopic. And Peter Liljedahl talks about it being really useful when students are doing some review before a summative task, that they can look at all the subtopics and then ask themselves their level of understanding of each of those subtopics. Some teachers might also use a navigation tool like this as an assessment tool. So this is what it could look like. So you can see there that we have the overall topic of grade 8 equations and inequalities at the top there. And then a list of subtopics, sort of the progression that a teacher might go through when they're looking at those topics. So you'll notice that for today, when you look through that list of topics, even though we're going to talk about inequalities, that's actually towards the bottom of our list here. That's actually after you've done quite a bit of work about vocabulary, evaluating expressions, solving equations. Inequalities comes toward the end there. Those 3 columns to the right, as I mentioned before, those are just there in case a student wanted to use this to do some self-evaluation, or if a teacher wanted to use this as an assessment tool when they noticed that students had a good understanding of each of these. In some other ways, a teacher might just make an anchor chart in the classroom of the overall topic and the subtopics where students can see where they're going. By the way, I want to say too, I should have said it at the top. If there's anybody has any questions at any point, don't hesitate to put a question in the chat or just unmute. Feel free to interrupt at any point. So after looking at that list of the overall topic and the subtopics, we do want to spend a little bit of time today looking at inequalities because that is new. So first, we wanted to set a context of where you might see inequalities in real life. So this particular slide actually comes from our long range plans website. So if you visited that, you'll know that there's some slide decks that are corresponding with our comprehensive math approach. So there's a slide deck, learning through problem solving, building fluency, and purposeful practice. So this is actually a problem in the slide deck for learning through problem solving. So I'm just going to take us to this so we can have a look. What does 2,000 calories look like? So when we look at this particular problem, it's by Robert Kaplinski. What does 2,000 calories look like? When we scroll down, he has a question here about eggs, the situation. And if we look at the questions down below, you'll see that there's how many calories are in one egg, and he has that information up top there for the students. How many blanks could you eat if you only wanted to eat exactly a certain number of calories? And you'll see there in brackets, that's where students would be looking at making a one-step equation and solving that. The next question, how many blanks could you eat if you only wanted to eat at most a certain number of calories? So, for example, he sets up a problem where if somebody only wanted to eat 2,000 calories, how could they work up to that without going over? So, that is an example where they could be making a one step inequality. One thing to note with this particular problem, and it does say this on the Learning Through Problems slide deck, is when you scroll through this problem, you'll notice that various foods are provided. So we've got bagels, donuts, eggs, bacon, Cinnabon, Big Macs, etc., McNuggets, large fries. So there's one word of caution when you're using a problem like this in terms of rehumanizing mathematics. And I know Rhonda put that term in the chat already. That all of the foods that are provided here are very sort of ethnocentric, white dominant culture type examples. So when you're doing a question like this, you always want to be thinking of the students that are in front of you in your class, and you would maybe want to provide some different options out there that might be more culturally relevant with the students that are in your room. Okay. Now we want to look at this problem. This one is also in our slide decks. So this is a question that you might ask of students in front of you. So create an inequality where 8 is a possible solution, but 9 is not. So use the expression 3m plus 10 on one side of your inequality. So I just want to give you a few minutes to think about this if you haven't had much of a chance to work with inequalities yet. That if you were trying to answer this question, what would you put on the other side of your inequality? So 3m plus 10 greater than, less than, greater than and equal to, less than and equal to. What would you put on the right side of the inequality that would work for this particular scenario? So if you want to take a couple minutes and think about that and then put any of your thoughts in the chat, that would be great. And if you're completely lost, you can put that in the chat too. We can talk about this question. So Lisa, I see your question. Do we have to use the number 8 in the equation as well? Yeah, so the way these inequalities work is basically if you were to substitute the number 8 into the left side of that equation, 3m plus 10. Whatever you put on the right side, it would work for. And if you were to substitute in 9 for the m, whatever number you put on the right side of the equation, it would not work for, as well as depending on which way you put your inequality. Giovanna's got 3m plus 10 less than and equal to 34. Does this make sense? Rhonda says it makes sense. Yeah, I agree. When I work through a problem like this, I tend to look at it as if I substitute 8 into 3m plus 10. So 3 times 8 is 24 plus 10 is 34. If I were to substitute 9 in there, so 3 times 9 is 27 plus 10 is 37. What I would tend to do is probably pick a number between 34 or 39 and put that inequality going in the right direction so that it would work for 8 but not for 9. Or as Giovanna said, if you choose right on 34, then you have an inequality that is also equal to 34 when you are substituting in the number 8. Okay, we're going to have a chance to look at some more questions like this, so I'm just going to keep moving. So, when looking at a question like that, we want to know our learners, and of course we have all sorts of different developmental comprehension levels in our classroom. So, in looking at this is the same slide we just looked at. In looking at this particular question, one thing that we might do in order to differentiate for the different needs that are in our class is do something like this. So it doesn't have to look like this exactly, but this is also from our slide deck. So this little icon up top here is just showing teachers that this is a parallel task. So students you can give them a choice, you can label them choice 1, choice 2, you can label them whatever you want. You'll notice that the first question is exactly the one we just looked at. So we're creating that inequality where 8 is a possible solution, but 9 is not. For that inequality, then on one side of the expression is 3m plus 10. I want you to look at choice number 2 there and think about the difference in that choice and what is different about it and what need it may be serving for students in your class. So what do you notice about the choices there? Yeah. So Lisa is saying in choice number 2, it just has sort of a one-step part to the expression on the left side. So there's just a 3m and then there's no constant or no addition. And Grace, choice 2, the range between possible and not possible is greater. Exactly. Those are the two differences there, that there's a much larger range of numbers that students could be putting on the other side of the inequality, and that it is just that one step instead of 2 steps. Choice 2, multiplying 5 and 10 may be more accessible to some students. Exactly. Okay, so some more friendly numbers for our students to be working with as well. Now, this particular parallel tasks only shows 2 choices. You might be needing to show 3 choices. You'll have to think about that in terms of the students that are in your room. Now, for knowing your learners. So we're going to shift this a little bit in terms of not just thinking about abstract students, but we want you to think about the students that you currently are working with. And here's an example of an open question. So not a parallel task, but an open question here that teachers might do in a number talk or might do with a minds on, where here's a question using inequalities that has that sort of low floor, high ceiling. that students can come up with all different reasons for which one of these inequalities doesn't belong and why. And you may have done some background knowledge on or some background on what these inequalities even look like on a number line, or some people would call this a graph as well. Or you might just even put this up and have them notice certain things about what's in the choices here and which one doesn't belong. So that's something important to keep in mind as well, that you can use those open tasks that all students in your room could have something to say.
Lene, just before you leave that
Yeah.
screen, I just want to make sure, just because we haven't ever done inequalities in intermediate before, making sure everyone's clear if you notice that there's an open circle on numbers and sometimes a closed circle on numbers.
Yeah.
I'm not sure if everybody's familiar with that, but the open circle would mean that it would be like in A, it's greater than, is that a six? Greater than six, but not greater than or equal to six. The closed dot emphasizes that it could be equal to that.
Exactly. Thank you for pointing that out, Rhonda. Yeah, that's important to note. So, when we look at designing tasks for your learners, and we are going to explore a little bit deeper how to design those parallel tasks, there's a couple of things that we want to keep in mind. So, to design appropriate parallel tasks, all students need to be working on the same big idea. So, for example, depending on when we were looking at that other question where there were the two choices there, actually, I'm going to go back. This one, okay? That we were looking at that big idea that they would know how to manipulate inequalities. However, when you're creating those parallel tasks, they're engaged in tasks that are at different levels of complexity. So, parallel tasks usually have two or three variations that are meant to meet the different developmental stages in your classroom, but they are similar enough to each other that in any sort of consolidation process, they could be discussed simultaneously. And you want to think about the fact, too, that this is going to contribute to your classroom as a learning community, that everybody needs something different in order to progress. With the two or three different variations, sometimes you might have one at grade level, sometimes you might have ones that are for students who haven't quite understood that concept yet. You have to remember that you may also have other students in your class that need sort of those extension options as well. So, a couple considerations or a couple of, I guess, frequently asked questions by teachers when thinking about parallel tasks is that you want to allow students to choose the task that feels right for them. So, it is empowering for your students to be able to choose what's right for them. If they choose a task that's too challenging, they can always choose the other task in order to build their skills and build their confidence. If they choose a task that's not challenging enough, they can always try another choice. So, as long as there's choices involved there, we're always going to empower our students to choose what feels right for them. And if they are open to taking an extra challenge, then they can do that. If they chose one that was potentially too difficult for them, they can always try one at a different level of complexity. So, we want to take a couple of minutes to allow you a chance to try this. So, with this question, which is an open question from Math Up, it says describe a situation to match each inequality. So, there's some possible solutions there if you're not used to sort of attaching a real life situation to inequalities. So, that first one, 4n plus 17 is less than 300. So, an example of a real life situation, maybe there's a five-sided shape with four equal side lengths and one side that is 17 units long. I know the perimeter is less than 300 units and want to know how long all the side lengths are. So, there's a real life example of an inequality, or one that is probably applicable more to students in their real life. The 160 minus 2n is less than 500 minus 6n. So on the left side, one person has a bank account with $160 and takes out $2 a week. On the right side, another person has a bank account of $500 and takes out $6 a week. So the equation describes the weeks that the first person has less money in the account. So what we want to try is if that was one of the choices that was available to your students to try and come up with a real life situation that might work for that inequality. There's a shared slide deck there. Rhonda, have you already put that in the chat? Nope, not yet. Okay.
I can do that for you though.
Okay, thank you. There's a shared slide deck. So what you'll see when you go to the shared slide deck is just that there's lots of slides that look just like this one. So you can choose any slide that you would like and see if you can come up with some different levels of complexity for this question that would suit the students that are in your classroom right now. So you might be thinking these questions, wow, this is way too complex for some students that are in my room. So you might want to make a choice that is less complex than the one that's there. Or you might be thinking about a situation where there would be some students in your class that would need something more challenging. So you could come up with 2 choices, 3, whatever you like. So we're going to give you, I don't know, 5 minutes or so to play around with that. So feel free to use one of those slides and enter any of your thinking there. Okay, is there anybody that wants to share some thoughts there, either in the chat or by unmuting? So, what were some of the things that you noticed that you needed to change in the question for the needs that were in your room? Or if anybody wants to talk about a student or a group of students in their class that they were specifically thinking about and how they provided those students with an appropriate choice.
Um, so when I was making mine, I was thinking about my IEP students, um, and ensuring that even students who maybe are modified at a couple grades below grade level could still access um, the question. So I did uh, easier numbers to multiply, which was 2n and 10n. And then for my choice 2, I just did 4n is less than 100. So I took out the constant for those
Absolutely.
kids.
Yeah, absolutely. So you use sort of friendlier numbers that you knew that they would be comfortable working with, and then using some one-step ones as well. Awesome. Is there anybody else that wants to share their thinking around what they created? Okay. Moving on. Okay. So, that was sort of the live portion of this evening's session about exploring some of your thinking about inequalities. So at the beginning of tonight's session, we mentioned that there was going to be the live portion. And then, of course, we really appreciate you coming to join us and talking about this, but we know that you have busy lives. You've been teaching all day. So now what we want to do is provide you with an opportunity to watch the 2 videos that are there. Rhonda's gonna drop the links in the chat, I think. So there's a video there about maintaining positive motivation and perseverance. So the focus within this topic, the SEL focus, there's a video there you can watch. And also a video on executive functioning. That's a focus that we're looking at in terms of how to help students initiate their work on certain tasks. And then, of course, Rhonda and I, you can watch these videos now, come back and ask us a question if you would like, or if you would prefer to just go ahead and watch these videos sometime on your own, or if you want to just stick around and ask us some questions, that's great too. I will also mention that these videos that Rhonda made are awesome and particularly entertaining. I don't know how many of you do this, that when you watch them on YouTube and you speed them up a little bit. So you can even watch them at 1.25 speed or 1.5 speed. And it's
And
very,
then hear me talk like this. I'll be talking like this the whole time.
yeah, yeah. And so it was great information and also entertaining. So I leave that up to you.
I just want to add something before you leave, or you can also just stay on, and if you have questions and want to just have a chat with Lene and I, that's cool too. The SEL piece, we are all still learning what that SEL piece looks like in math. So this is our current understanding. As we learn more about how to best implement SEL in the classroom and in a math classroom, these may change over time. So this isn't a stand in stone. This is the best knowledge that we have at the current moment. Next year, it might look different. Just giving you a disclaimer on that one. And I'm also going to stop recording now so that the Q&A period will just be between us. It won't be a recording.